Welcome to David Alexander Maths Tuition. This is Chapter 9G, Transforming Trigonometric Graphs. So what's the difference between the graphs of sine x and sine x plus 1? Well, the graph of sine x plus 1 is the entire sine graph just shifted up 1 unit. So let's just think about what sine looks like. It starts at 0, goes up to 1, goes back through 0, goes down to -1 and back up to 0 again. So the key thing is it's got a maximum of 1 and a minimum of -1. So if we're just shifting this whole graph up 1 unit, then this minimum will then be 0, this maximum will then be 2, and when it cuts through at 0, they'll be just cutting through, well, it won't be cutting through, sorry, it will just be getting a value of 1, so it will look like so. Okay, there's a fairly poor sketch there. So the green, this is the sine of x, and the blue is the sine of x plus 1. So here the transformation is just outside the function, so all we're doing is we're just moving the whole graph up by 1 unit. Okay, so if the sine of x plus 1 meant we're just moving the graph up 1 unit, the sine of x minus 2 means we're just going to be moving it down 2 units. So it's just a vertical translation. This red line is the sine of x, and if we just take a random point like here, this maximum point is just going to be moved down 1, 2. So instead of it being 90 degrees 1, it's 90 degrees minus 1. So all it is just vertical translation. The entire graph is just moving down 2 units. So when it's the sine of x and then you've got plus or minus something, just remember that's the sine graph just being shifted upwards or downwards. Really, really easy to deal with. Okay, what about sine of x and 2 times the sine of x? Okay, so this is the sine of x. Now this could also be my sketch for 2 sine x, because I've not actually put any values in. Now we know if I'm making, if I make this point here 1 and this -1, then that is the sine of x. The sine of 2x, I'm just doubling these values, so I can draw pretty much an identical curve, but as long as I mark that as 2 and then -2, then that is 2 sine of x. So when you've got a number in front of the sine of x or the cos of x, then that is just a stretch with a scale factor 2 parallel to the y-axis. So it's just a vertical stretch with a scale factor of 2. So let's just take a look here. Here is the red sine curve and the blue. So this is the red is the sine of x and the blue is the sine of 2x. So it's cutting through at the same points. The only difference is it's just being stretched vertically with a scale factor of 2. If it was 3 sine x, it would be stretched with a scale factor of 3, so the maximum would be 3. Okay, what about the difference between sine x and the minus sine of x? So here the transformation is outside of the bracket, so here that means it's going to be affecting the y values. So here's the sine of x, so if it's affecting the y values, all it means is we are just changing the sign of any y values, so any positive y values will be made negative and any negative y values will be made positive. So in other words, what we have here is a reflection in the x-axis. So it's handy just to remember that minus the sine of x is a reflection in the x-axis. Okay, so the green line, that is y equals the sine of x, and the blue, that is the minus sine of x. As you can see, it's being reflected in the x-axis there. Okay, so what is the difference between the sine of x and the sine of negative x? Well, here the transformation is inside the bracket, so therefore we're going to be changing the x values, and it means we're just going to be changing the signs of all the x values. So a positive x value will become negative, a negative x value will become positive. So let's just draw the sine of x, which will look like so. And of course, if an x value negative is becoming positive and a positive is becoming negative, then that means it's a reflection in the y-axis. So if I reflect this in the y-axis, I will have a sketch that looks, I'll have a curve that looks like this. So this part here is a reflection of this bit off here that I've not actually drawn. So what's the big deal here? Well, nothing really, except that when you reflect the sine curve in both the x-axis and the y-axis, you get the same thing. If I were to reflect on the x-axis, then this hump here would be like so, and this would be like that. So what we need to remember is, well, the previous slide, the minus the sine of x was a reflection in the x-axis, and the sine of negative x is a reflection in the y-axis. But since they are the same, that it's always handy, well, it's kind of handy to remember that negative sine x and the sine of negative x are the same thing, because when you reflect the sine curve in the x-axis or the y-axis, both those curves will sit on top of each other. Anyhow, so the green line, that is the sine of x, and the sine of negative x is the blue one. Again, it's a reflection in the y-axis, although that's not particularly obvious because we haven't got much visible in the well, I've just chopped the graph off very shortly after 0, but you can also see that this is also a reflection in the x-axis as well. Okay, so sine of x and the sine of 2x. So the sine of x and the sine of 2x are different. What we need to remember is the sine of 2x is a stretch with a scale factor of 1/2. So scale factor half parallel to the x-axis. So it's being stretched horizontally with a scale factor of 1/2. But if it's been stretched with a scale factor that's less than 1, that won't feel like a stretch. We'll actually be sort of compressing it, the curve. So actually probably an easy way of thinking of it is, here is the sine of x between 0 and 360. So if we're stretching it with a scale factor of 1/2, meaning we're actually going to be compressing it, the easiest way to remember this is it's just, instead of one sine wave between 0 and 360, we're going to get two sine waves between 0 and 360 degrees. So let's just take a look on Desmos. The green is the sine of x. So we can see 0 to 360, we are getting one full sine wave, but for the sine of 2x, we're going to get, there's one up to 180 and a second one up to 360. So that's the key thing to remember. The sine of 2x, you get two sine waves between 0 and 360. The sine of 3x, you'd get three sine waves in between 0 and 360. Seeing it as a scale factor of 1/2 parallel to the x-axis does make it seem a little bit more confusing, mainly because you're seeing it as a stretch, but it's not really being stretched. If you felt like a stretch would be taking this green line and pulling it to the right, but actually we are pulling it in the opposite direction because it's a stretch with a scale factor that is less than 1. Okay, so here we've got the difference between the sine of x and the sine of, let's turn that into the sine of 1/4 x. So this is a stretch with a scale factor of 1/1/4, so a scale factor of 4, and that's a stretch parallel to the x-axis with, as I said, scale factor 4. So this will seem more like a stretch. So we're stretching that sine curve out. So between 360 degrees, the sine of x, I'm getting the full sine wave in. But if I'm stretching this with a scale factor of 4, that means that I'm only going to get 1/4 of the full sine wave in between 0 and 360. Up to here, that's half a sine wave. So 1/4 of the sine wave is just this little arc here. So all we're doing is squeezing that in. We're just going up to our maximum point between 0 and 360. So there we go. So as we can see, we've got the full sine wave between 0 and 360, but only 1/4 of the sine of 1/4 x between 0 and 360. Okay, what about the difference between the sine of x and the sine of x plus 90? Well, here the transformation takes place inside the bracket, so it's going to affect the x values, and we do the opposite of what it says. So we're going to subtract 90 from the x values. So all that means is the sine curve is going to be translated 90 degrees to the left. So here is the sine of x, and this is 90 degrees here. So if I'm moving this all back 90 degrees, then instead of me getting my maximum value of 1 when it's 90, I'll get my maximum value of 1 when I am when I'm on 0 degrees. And it will look like so. And so if I'm moving that back 90 degrees, does this curve look familiar? It should do, because this is the cos of x. So the sine of x plus 90, it's handy to remember that that is exactly the same as the cos of x. So there we have it. Here is the green line, that is the sine of x, and all we are doing is just shifting the whole graph 90 degrees to the left. So we just need to see that as a translation to the left by 90 degrees. Okay, so if the sine of x plus 90 was a translation 90 degrees to the left, then this is a translation which is 180 degrees to the right. Remember, the transformation is taking place inside the bracket, so it affects the x. We do the opposite of what it says. So we're adding 180 degrees to all the x values. So if I just shift this, so this is 0, this is 180. So therefore this point here will start here. So actually, maybe if I just do this as a dashed line. There we go. So the sine of x minus 180 degrees, that is actually, we can see that is a reflection in the x-axis. So there we have it. Green is the sine of x, and blue is the sine of x minus 180. As we can see, it's been moved. 90 goes to 270, so that is plus 180 degrees in that direction. So it's a shift sideways to the right, 180 degrees. Okay, so what's the maximum and minimum value of the sine of x? Well, this is just something we just need to remember. So we just need to remember that the maximum is 1 and the minimum is negative 1. Okay, so max equals 1, min equals negative 1, and what is the smallest positive or 0 value of x for which each maximum and minimum occurs? Okay, so what's the value that will give us this 1? Well, this is 360 degrees, so this is 180 degrees, so this is 90 degrees. So in terms of coordinates, it's going to be 90 degrees maximum of 1. And the negative 1, well, if this is 180, this is 360, then halfway between is 270. So 270 degrees gives us that first minimum. What is the maximum and minimum value of 5 cos x? Okay, so let's just do a quick sketch of the cos of x. So the cos of x will look like this between 0 and 360 degrees. So that is 180. Now the maximum is 1 and the minimum is negative 1 for cos of x. But for 5 times the cos of x, the maximum is positive 5 and the minimum is negative 5. So it's quite easy, the maximum and minimums when it's just the number that's in front of the x there, in front of the cos x there. Okay, so so the maximum is 5, the minimum is negative 5. So what's the smallest positive or 0 value of x for which each maximum and minimum occurs? So the first maximum of 5 occurs when x is 0. So we've got 0 degrees 5, and the minimum we can see is at 180 degrees. So 180 degrees negative 5. What's the maximum and minimum value of 13 sine x? Well, the maximum and minimum value of the sine of x is 1 and negative 1. So if it's 13 sine x, then it's positive 13 and negative 13. So max is 13, minimum negative 13. And what is the smallest positive or 0 value of x for which each maximum and minimum occurs? So this is 360, this is 180, so this here will be 90. So 90 degrees 13, and the minimum will be halfway between 180 and 360, which is 270. So 270 degrees negative 13. What is the maximum and minimum value of minus 12 cos x? Okay, so the cos of x looks like this. So the negative cos of x, well, first of all, let's think about 12 cos x will be the same as cos of x, but instead of a maximum and minimum of 1 and negative 1, it's going to be 12 and negative 12. But if it's minus 12, then this is just going to be a reflection in the x-axis, because sometimes it's quite difficult reflecting them. So where are we getting? So the maximum we know is 12, the minimum is negative 12. Where are we first getting the maximum of 12? Well, that's at this point here, which is, so this is 0, this is 360. So it's halfway between 0 and 360, so it's 180 degrees, gives us the maximum of 12, and the minimum of negative 12 is when x is 0 degrees. So 0 degrees minus 12. We also get a minimum of negative 12 at 360, but that is not the smallest positive or 0 value. What is the maximum and minimum value of the sine of 3x? Okay, there's no number in front of the sine of 3x, so the maximum is still 1 and the minimum is still negative 1. So let's just do a little sketch of the sine of x first of all. This is the sine of x between 0 and 360. So a maximum of 1, a minimum of negative 1. So what is the difference between the sine of x and the sine of 3x? Well, the difference is you get 3 sine waves for the price of 1 in any given interval. So here is the interval 0 to 360, that is the sine of x, 1 full sine wave. So the sine of 3x means we're going to get 3 full sine waves between 0 and 360. So there's a second sine wave, and here is a third one. Okay, so this point here is 360 degrees, and this is a little sketch of the sine of 3x. Okay, so where I'm getting the positive 1 at this point here and negative 1 at this point here. Right, let's work backwards. So 360 degrees is 3 full sine waves, so 180 degrees is going to be 1.5. So there's 1 full sine wave, and there is half a sine wave. So this point here is 180. So I've got 1, 2, 3 lumps here. So at the start of each of these lumps, that's going to be sort of 180 divided by 3, 60 degrees less. So that is 120 degrees, that is 60 degrees, and that we know is 0 degrees. Now this maximum here is halfway, okay, it's not drawn it brilliantly, it doesn't look halfway through, but it's halfway between 0 and 60, so that is 30. So at 30 degrees we're getting that first maximum of 1, and 60 plus 30 is 90, so at 90 degrees we're getting our first minimum. What is the maximum and minimum value of cos of 0.5x? There's no number in front of the cos there, so the maximum will still be 1 and the minimum will be negative 1. So let's just have a look at our graph of cos of x between 0 and 360 degrees. Okay, so there's 360 degrees, so if it's so we've got our maximum here of 1, our minimum of negative 1. Now the cos of 0.5x means we're only going to get half of this number of sine waves between 0 and 360. So between 0 and 360 for the cos of x we're getting 1 full sine wave. So for the cos of half x we're only going to get half a sine wave, so up to here. So it starts at 1, goes down, and okay, so this point here is 360, and this is the cos of half x, or 0.5x. Okay, so the maximum, our maximum is when x is 0, so 0 degrees will get us that first maximum of 1, and the minimum will be at 360 degrees. So 360 degrees will give us our minimum of -1. So for this question, all I need to do is just do a sketch of negative sine x. Always a good starting point is often just to do the normal sine of x, which looks like so between 0 and 360. So this is a transformation that takes place outside the bracket, so it's affecting the y. We're just flipping the signs of the y value. So if a y is positive, then it will become negative. If it's negative, it will become positive. So what this will result in is a reflection in the x-axis. So minus sine x will look like this between 0 and 360. So maybe you need to label 360, 180, label that as 1 and that as -1. -3 cos of x, let's start off with the cos of x. So the cos of x starts at 1, goes down to -1, comes back up again. Now 3 cos of x, instead of going up to 1 and -1, goes up to 3 and -3. And again, we're just applying this transformation. We are, well, the transformation's outside the bracket, so it's going to affect the y values. So positive y values will become negative, negative y values will become positive. So that is therefore, again, a bit like the previous one, that is just a reflection in the x-axis. So starting at the bottom, going up to the top, and back down again. So I don't know why I've done it with the dashed line, but there we go. Maximum of 3, minimum of -3. This point here is 360, this is 180, so this is 90, and this is 270. Sometimes they ask you to mark points where it crosses various axes. Okay, so the cos of -2x. First of all, let's do the cos of x again. So the cos of x looks like so between 0 and 360 degrees, with a maximum of 1 and a minimum of -1. Now, what does the cos of 2x look like? So the cos of 2x between 0 and 360, means we are getting twice as many cos waves in, so we're getting two in for the price of one. So there is one, and there is our second. So not the greatest, and that is 360. Okay, so the same interval, 0 to 360, but we're getting twice as many cos waves in. However, we want to apply this transformation, so it's inside the brackets. It's going to affect the x values. So positive x values will be made negative, and negative ones will be made positive. So what this means is this just a reflection in the y-axis. Now the good news is that cos has a line of symmetry in the y-axis. So if I were to draw this the other way, we can see, well, if I drew it properly, or if I use Desmos, you can see that this is a reflection of the other side. So actually, the cos of 2x is identical to the cos of negative 2x. So it would look exactly as I've drawn it here, again with a maximum of 1 and a minimum of negative 1. Okay, so the tan of x plus 90, we want to be thinking about our tan, so it goes through the origin. First asymptote is at 90, and the one previous is minus 90. Okay, so this is a transformation that takes place inside the brackets, so it's going to affect the x values, and we do the opposite of what it says, so we're going to subtract 90, so move everything 90 to the left. So therefore the new asymptote, the current asymptote is 90, so the new asymptote will be the y-axis itself. So if I just draw a tan curve, and there is my y-axis, and here is my x-axis. Okay, so this asymptote here will be 90 degrees further, so that will be minus 180. So now none of this is what is required between 0 and 360 though, but it's sort of guiding me in the right direction. Now the next tan wave will look like, well, the previous one, of course, they're all the same. So first asymptote negative 180, the next one will be at 0, the next one will be at positive 180, and we're going to get another tan wave in, and that will take us up to 360. So for this sketch, all we are interested in is this part here. Okay, so here is another one, the minus sine of 4x. So let's start off with the sine of x, easy peasy. Positive, maximum 1, minimum negative 1. So a sine of 4x means I'm going to get 4 sine waves for the price of 1 in the same, in between 0 and 360. So there is 1, there is 2, there is 3, and there is my fourth. So this is the sine of 4x. And I just need to think about this transformation. It's outside the bracket, so it's going to affect the y. So positive y's will become negative, negative y's will become positive. So in other words, this is a reflection in the x-axis. So this is what it will look like. So if I just draw that on its own, so there is 1 sine wave, 2, 3, 4. There we go. And this is 360. And again, we can just show that that's positive 1, and that is negative 1. So, you know, it's not the best looking graph in the world, but, you know, it does only say sketch. And as long as I'm seeing 4 sine waves, it's not really the end of the world that some might go a tiny bit higher than others, for example. Obviously, if you're doing it on graph paper, it's a lot easier to get it a little bit more accurately than what I've done. Okay, so let's think about the tan of 2x, shall we? So let's do the tan of x. The tan of x will look like so, and the first asymptote is 90, and this one's negative 90, and it's going through the origin. So for the tan of 2x, I'm getting twice as many tan waves in any given interval. So everything is just going to be sort of like squished in by half. So for the tan of 2x, I can just draw it exactly the same as before, but this asymptote is going to be half of 90, so that's going to be positive 45, negative 45, and that is the origin 0. Now usually tan repeats every 180 degrees, but the tan of 2x is going to repeat every 90 degrees. So our next asymptote is 45 plus 90, and 45 plus 90 is 135. Let's draw in another tan wave. Our next asymptote again is 135 plus 90, which is 225. And if I add another 90 onto that, that takes me to 315. and if I do the next asymptote, then I'm beyond the 360. So let's just think about how much of the graph I need to draw. So we've got 0, so this is 0 plus 90, so that is 90, 180, 270, so the next intercept with the x-axis will be 360, so there we have it. So again, not perfectly drawn, but we're only really interested in this part here because we're only interested from 0 onwards. So the tan of 2x between 0 and 360 looks like the tan of x between 0 and twice of 360, 720, in terms of the number of waves we're going to see, but all the asymptotes and all the x-intercepts will just have different values. So sometimes they can be a little bit tricky. That was definitely the hardest of the ones that I've demonstrated, in my opinion.